Welcome to Turn Right Machine Works. My name is Keith. Today we're going to continue on the Benchmaster crankshaft, and we're set up here in the lathe. The first part we're going to make is going to be the straight shaft. This straight shaft is one dimension all the way. 3/4 inch is the nominal, but this kind of shaft here, we got to talk about holding it within tenths. And the eccentric that creates the crank motion of this item is supposed to be press fit onto the shaft so that it doesn't slide. Even though in reality there's no side thrust to this crankshaft, everything is pretty well straight in line. If you have a worn bearing or misalignment on your belts, on your pulley, there's some other things that might cause it to shift side to side, but for the most part everything runs in a straight axis and there should be no side thrust. Therefore a thousandths press or so should be fine on this hub here to hold it in place. Now our piece of material here, 4130, is our choice of material here, just because it's bringing in similar alloys as the 4140 and stuff, but it's got high impact in it, and I kind of like that. Especially, you know, you got things flying around on there, and we got some woodruff keys in here and stuff like that. I want you know, and you can see when you think about that woodruff key being cut down in there, the stress rising areas in there on a pounding. You know, it's kind of why I chose the material. A lot of, whether it's actually that's what they made this out of, I have no idea what they actually made this out of. I do know that I file checked it, and it grooves very softly, so it's not a heat treated item. But I do think that the having the alloys of chromium and stuff is a important fact on something like this. All right, we're gonna go ahead and we're gonna set this up. We're gonna cut it close to length because we're about 1.5 inches or so long on this piece of material here. And then we're going to center drill it, and then we're going to set up and we're going to run this thing between centers. The reason why I like to run things between centers is this is an old chuck, and I can get a lot of things to run true in it and everything else, but and I do need to regrind it, and I haven't got the right setup yet for it. You can grab a hold of it right here and have one center and turn the whole rod and have it all done. Except for if the force of that jaw is tendon, especially we're talking about a narrow part here. We're not talking about a big mass like having a rod like this. So the chuck in reality can hold this and hold it off center. So you could have this center drilled here and be turning this, and then when you release it, your material is gonna take the set that it was turned at. All right, we've got this marked here, and we're gonna go ahead and part off our piece of material. And then we're going to set it up in a steady rest and do the center drill. Trying to do here is to claim a true center drill at both ends. And we're going to do a quick face and then center drill. set up between centers now. Alright, this is the center that we're going to chuck on, and of course this has been trimmed and faced because every time you put it in, you take a skim cut on this to make this taper true running with the lathe. Otherwise, you know, putting it between centers, it wouldn't matter. You know, you can put any old pointed thing in there and hold the end of your shaft. So anyway, over about 7 years or so, this has probably worked its way back about 3/4 of an inch. But I usually just turn a shank and a shoulder so that you can set that thing right in against your jaws, and the pressure and everything else right there is going to be fine. Once you tighten it down, you can see she runs fairly true, but if you were to put an indicator on here, and you would see that that's about 3/4 thousandths run out. Alright, sorry about a little bit of the fan noise here, but it's like 85 degrees in here already and we're only at 9 o'clock in the morning. You know. It's a cool one though. Yesterday it was over 90. And that's here on the Cape. Mainland must have been real tortured. Alright, we're swinging our compound around. This included angle is 60, so we're gonna crank in about 30 here. Move our tool bit around so that our cut angle is sufficient here. Alright, you always want to check your running travel, making sure that you can get the whole thing. Give it a little support. Skim a couple thousandths off of there just to make it round. So as long as it's true and you have no holidays, you're good. Alright, now that's true and you can use it like that, but I like to take the file and just draw past a couple of just to bring that gloss in there so I know that I'm hitting firm material. With the raised up surface there, you could be wallering or mushrooming out some material in there. Now that's a sharp point. I like to take my my trashy file, just meaning the lowest one on the food chain here, so to speak, and it's for doing edges and points and everything that you don't care about clogging up your file. All I do is break that right there, just so it don't stab in the back of your hand and things like that. Now everybody has a favorite place that they like to, you know, set their compound in a normal position. Alright, so we're going to move it off of the 30 we use for the center. My favorite position is the position to be threading. That way it's always ready for a thread and you don't have to second guess it. Everything else is extra. You know, if you're putting a 45-degree chamfer on a bore, you might have had it at 45 degrees, or you're doing a short angle and you got that cut up. But as far as general turning, and it fits all around in my realm of moving around room, is what I'm trying to say. I favor the 60-degree included angle for the threading. So it's really only 30 degrees off of your straight end axis. Although on my protractor here it does say 60. So You know, each lathe is laid out a little bit different. The increments are all going to be out there. But we all know that when you're looking at the drawing board, 0 is horizontal, okay? So, anyway. Alright, now we're going to be setting up, we've got some extreme pressure lube. Is a special grease made for lubing center holes that are going to ride and become a bearing. This point is really a bearing point because if your shaft is not true in line, it is acting like a universal joint on there. So, and however minute the amount of alignment is out, it is creating a little bit of friction as it rotates, and that extreme pressure lube handles and reduces the wear on your center. And we're going to have this is a dog. I welded on a little extension just because it suits my almost every need for the size shafting that I can run with this dog. And a piece of aluminum you always keep underneath your dog bolt there. Okay, we're going to go ahead and we're going to put a little extreme pressure lube in both of these, and we can add some anytime we want. This one tube is probably almost 20 years old. I believe you can still get the same brand and everything else nowadays. Alright, we slip the dog over and we put that center in there. And we bring this one on up here, make sure it's clean. Alright, and the centers you want to start out just a light, you can still lightly turn it. Alright, we'll lock down the tailstock. Okay, now we're going to set up the drive dog. I'm going to crank our table over here so we got more room to work here. Now the drive dog just needs to be locked onto here and go against the chuck here. And that's what drives it. We can move it in. Actually, we're going to trade this for a little square. The reason why we're going to do that is it maximizes how far we can come in here and turn. But you know, we're not going to be stingy. We're going to endo it several times. We got to get it to run true. We want to eliminate our taper. All right, we tighten our dog bolt here. All right, now we're going to go ahead and give it some RPM. Yeah, it's running pretty true. We'll just throw an indicator on here just to, you know, this is set up. This is raw material. Also, too, the reason why I mean, I don't know if we could have got ground material, but this is like cold finished material, and in the tolerances in the material book when I purchased this, they give you plus and minuses, and we mic'd this up, and actually we're glad we made the choice, because if we would have went for the 3/4, we would have been about 3-4 thousandths under that 3/4. Okay, now about 1 thou and a quarter, 1 thou and a half right there in the middle. About 2 right there. It looked like it's kind of egg shaped too. It wasn't constant. And about 1 1/2 there. All in all, that's you know, we're set up nice and